Hello, students. Hope you're doing good. I'm going to go over this topic, which is called composition of two functions. So it's like an operation on two functions like addition, subtraction, multiplication. This is a totally different operation and it's called a composition of two functions. So let's look at the definition first. Given two functions f and g, composition of f and g is a new operation denoted by this little circle O. This is O, it's not a dot. So usually if I write f dot g, that means it is multiplication. I'm multiplying the two functions. And if you remember, f dot g, this is my dot here, of x is just simply multiplying the two given functions f of x and g of x. Now, composition is denoted by the letter O, a little o, written as FOG, and is defined as FOG of x is f of g of x. So it's not f of x g of x as in the multiplication. This is f of g of x. So the input here is g of x as compared to x. So let's look at another way to define the composition. Suppose I start with an input x as we usually start in the functions. So starting with this input, this right here is my input. So starting with this input x, first you apply g. I'm doing FOG right here. So when I'm doing FOG, first I apply g, whatever rule that g has, whatever function that g is. So first apply g on x, then you have a certain output right here, which whatever that output is, write it here. So this is your output, g of x. And then you apply f on that g of x. So the input for f is not x. The input for f now is whatever g of x is. So f applied on g of x gives you f of g of x. And that's how we define f o g of x. So again, first g is applied to x, given any input, first g is applied to x, and then f is applied to g of x, and that's how composition works. Let's look at the few examples. Let's look at this first example. So let me make it a little big. Um, so the function is f of x equals x square, and your g of x is 2x plus 3. Let me move it a little bit on this side. So f of x is x square and g of x is 2x plus 3. So always two functions are given whenever we are talking about the composition or any operation we want to calculate. So we have a parabola f of x equals x square and g of x is a line with slope 2, right? Positive slope 2. So if I want to find, these are the given things, these are the things you need to find. FO g of x, FOG applied on 3, GO f of x, and G. So again, you can have FOG or GOF. Both will be totally different. We'll see when I calculate these. So now to calculate first of FOG of x, I will do f of g of x, which is f of, now this is my input right here, g of x. So the input of f is g of x. So the input of f is, what is my g of x? 2x plus 3. So that goes right here, 2x plus 3. What's the rule associated with f? What does f do to any input? F squares the input, right? This is what f does. So if input is 2x plus 3, it's going to square 2x plus 3. So your answer is 2x plus 3 whole square, which is FOG of x. Now, if your input is 3, if it's a number, real number 3, then you just plug in your 3 into this new function, which is FOG of x. So I plugged in 3 right here, as you can see. This is my 3. So 2 times there, instead of x, I'm writing 3. So 2 times 3 plus 3 squared, which is 6 plus 3, 9 squared, and that's 81, right? So now g of f of x, going the other way around, is same as g of f of x, which is same as g of, what is your f of x? F of x is x square. So what is your g? G is a line 2x plus 3. So instead of x, my input now is not x, it's x square. So I'm gonna write 2. Instead of x, I'm writing x square here because my input is x square. So instead of x, it's x squared plus 3. So as you can note here, these two are entirely different. FOG was 2x plus 3 whole squared, and GOF is 2x squared plus 3. Now GOF evaluated at 3, just replace x by 3. So 2 times 3 squared plus 3, which is 9 times, this is 9 times 2, 18 plus 3, and that's my 21. So that's how your GOF and FOG are calculated. Let me show you another way of actually calculating the diagram that I had before. So if I go according to the diagram and I'm calculating, let's say, FOG of x. So what I do is I start with an x and I apply g first. So what does my g do? G makes x to 2x plus 3. My output for g is 2x plus 3. Now I apply f on this 2x plus 3. And what does my f do? F squares everything, right? F is just squaring anything. So if I apply f on this particular input, it's going to square this. So this becomes 2x plus 3 whole square, right? So this is my FOG, and that's what I calculated here. And similarly, if I have GOF of x, I have, again, I start with an x, but I apply f first because you go from left to right, sorry, right to left. So you apply f first. If I apply f, I simply get x square. And then I apply g. So where is my x in g? It's 2x plus 3. So I now have 2x square plus 3. Right? So that's how we calculate. That's another way to calculate GOF and FOG. You can input any value, whatever value is given, 3, 4, -1 in the place of x, and then get the same function. Okay, let's go to the next one. So that's my next example. Suppose you have these functions now. F of x equals 3x minus 7 and f of x equals g of x equals square root of x, right? So again, f o g of x, if I just do by definition, it's f of g of x, which is f of g of x is square root of x. So f of square root of x, which is, where is my x? What does my f do? F is basically 3x minus 7. So my new input is square root of x right here, which becomes 3 square root of x minus 7. So instead of 3x minus 7, it's 3 square root. The g of x takes this place, 3 square root of x minus 7. Similarly, FOG of 4, if I ask you to calculate this, just plug in 4 in place of x, which is right here. Square root of 4, which is 2. So 3 times 2 minus 7, which is -1. Now GOF of x, on the other way around, it will be g of f of x right here, which is g of 3x minus 7. And g is just the square root of any input, so it takes the square root of 3x minus 7. If I do GOF of 4, just plug in 4 right here, which will give me a square root of 5. Okay, so that's another example. Let's look at another one. So what I want you to do is do this problem first. When f of x equals 4x plus 7 and g of x equals 3 absolute value of x, what will be your FOG right here? What will be your GOF? What will be FOG of -1 and GOF of -1? You can try this one and then let me know what do you get. The second problem I want you to do is this one. So this is my first one. The second one is, let f of x, let's take two lines, 2x minus 5 and g of x equals 3 of x minus 7. So you find FOG of x, the same thing, and GOF of x. Also, you find FOG of, let's say, any input 3 and GOF of -3. right? Or let's say both are 3. The another thing I want you to answer in problem 2 is also write the domain and range of both of these functions. Domain and range of FOG and GOF. Okay, so whatever your answers are for FOG and GOF, write the domain and range as well. So once you are done doing these problems, please enter the answers in the discussions post. I will be posting a discussions. So enter these two answers in the discussions post. Okay, take care. Bye bye.